Hi chemistry friends. I wanted to go over some percent composition because I am not there with you. So we'll just roll right into it and I'll show you how to do the lab as well. There's another video online that I posted if you want another reference or you don't want to listen to me. So percent composition is exactly how it sounds. A percent, right, is a part out of a whole, and a composition is something like what it's made of. So in chemistry, what we look at is we might take a particular molecule or ionic compound and we might look at what is the composition and what is the percent of that. So what are the parts making up the whole? And an example might be something like water, right? If we look at the water molecule, there are 2 atoms of hydrogen and 1 atom of oxygen. And we can actually do a percent composition just like that. There's 2 particles of hydrogen for all 3 particles in 1 molecule of water. There is 1 atom of oxygen for all 3 atoms in the molecule of water. But it's not very effective to do that because, like we've been learning, we cannot count particles. So we tend to do a percent composition by mass, and so that's what we're going to spend our time learning about. You know, in the book they actually show you both. For our intents in class, we're really just going to look at the percent composition by mass. So we're going to look at each part, what percentage of mass of water is hydrogen, what percentage of mass of water is oxygen. Okay, so let's practice that. So if we look at water, and you have your periodic tables out, and you have your calculators out, we can look up the mass of hydrogen on the periodic table, we can look up the mass of oxygen on the periodic table, we can add those all up to get the molar mass, which we've been doing, right? The molar mass of water. Some of you might even have it memorized by now because you've been using hydrogen and oxygen so much. But if we do the hydrogen is about 1.0078 grams. And there's 2 of them, so I have to multiply that mass by 2. And then the oxygen, there's 1 of them, so I take that times its molar mass, which is 15.99. If I add those up, you should get about 18.02 grams per mole for water. Okay. Now if I want to do the percent by mass, I literally just take the parts So I take the 2 times 1.0078, and if you want to round to the thousands place or the hundredths place, that's fine. Don't get overly rounding happy that you're at the ones place or the tenths place, just because your periodic table does give you your masses out several digits. Try to utilize that. But if I want to do the percent by mass of hydrogen, and I am rounding, I would do roughly 2.02 grams of hydrogen over 18.02 grams of the water times 100. What do we get for that percent? This is going to be my percent hydrogen by mass for hydrogen in the water. You should get about 11.2%. Hydrogen by mass is the percent composition of hydrogen in water. If you're at like 11.1, 11.3, if you take it to 11.24, whatever it ends up around there, you'll get credit for, so you don't have to worry too much about that. The question might be specific and just say calculate the percent composition by mass of hydrogen in water and then be done. It might say calculate the percent composition by mass, and then you might do every element that's in that molecule or in that compound if you're talking about an ionic compound. So we can do the percent by mass of oxygen. Since there's 1 oxygen in every water, we're going to do 15.99 999 grams oxygen into the total, and then times 100. So the percent oxygen, I'm going to write oxygen because sometimes the O looks like just an O or a 0 or part of the percent. So if we do that, you could have gone through all this effort and do it this way, just so you're practicing, right? But what you should get is 88.8% oxygen. You know, I could have found it the other way. If my whole molecule is 100%, I could subtract that 11.2% of hydrogen to get the 88.8% oxygen, or I could go ahead and calculate it by the part in the whole. Either way is fine, as long as you're showing me the work and your numbers have units. I am good with that. Also just note that I am using grams. Again, we don't see AMUs, so we're just assuming from here on out that we're using a mole of particles. I don't always have to use Avogadro's number. I just have to know that when I'm talking about reactions, I don't ever just have one of those particles. I have a whole group of them. Okay? So that would be the percent by mass of hydrogen and oxygen in a molecule of water. Pretty straightforward, pretty easy. If we wanted to go a little bit more complicated, I like to look at glucose. If you remember, glucose is C6H12O6. Glucose is super important in the cellular respiration, and I mean, I really like glucose because I really like sugar, and you guys are going to get to have a little sugar today in our little lab that we're going to do. It's more of like an activity than a lab, but you could do the percent by mass of the carbon, hydrogen, and oxygen in glucose. So just to work through this, the percent carbon is going to equal the mass of the carbon 6 times what you find on the periodic table. The mass of carbon, if you look on the periodic table, is 12.011 over the total mass of glucose. So why don't you just take a minute here to go through and find the mass of the carbon, the mass of the hydrogen, the mass of the oxygen, and then we'll go through it. You'll notice over here what I'm going to do is I'm just going to do like my little whole molar mass work over on the side. So if you're wondering where I'm getting these numbers from, they're all from the periodic table. The molar mass of carbon is 12.011. I have 6 carbon, as you can see in the formula, chemical formula. Hydrogen is 1.0078. I know that gets kind of sloppy with me trying to write on a vertical surface. Sorry about that. So there's 12 of them, and then there's 6 oxygen. So this isn't a 0, this is an O. 15.999. Some of you might have 16 on your periodic tables. That's A-okay with me. Very close. So if we do the 6 times 12.011, and if you don't want to do the work twice in your calculator, you can get everything set up that you are kind of working 2 ways at one time. So the mass of the carbon, 6 times 12.011, is 72.066 grams. The mass of hydrogen is 12 times 1.0078, which is 12.09. And again, you don't have to go out 4 digits. 094 is fine. And this is for the hydrogen. This is for the carbon. And then the mass of oxygen is going to be 6 times 15.999. So I'm just going to move this up just a little bit. Percent oxygen is going to be 6 times 15.999, and then your total molar mass is 180.154 grams. So I'm going to get this down so you can see this. And you can do it each step if you want to. I'm trying to save myself time putting it in the calculator. Now, part of the whole, so for the carbon, I'm going to take that 6 times 12.011 and divide that by the total, 180 times 100, to get my percent carbon. So 72.066 divided by 180.154. You get about 40%. The hydrogen is 12.094 divided by the total 180, roughly. You should get about 6.7% by mass. And then you could add the two of those up and subtract them from 100 to get the percent oxygen, or you can go through the division and do the 95.994 divided by the 180 and get 53.3%, which all of these should add up to be 100%. And then you have your percent composition of carbon, hydrogen, and oxygen and glucose. So that's that one. Okay, now we're going to just take a peek at the Smartie lab that you're going to do for today. So in the Smartie lab, what you're going to do is you're going to take your little package of Smarties and you are going to look up, and I'm going to go to the data table on the second page. You're going to look at your package, and if you have 2 red, you're going to put a number 2 here. Okay? If you have, 3 orange, you're going to put a 3. If you have 0 yellow, you'll put a 0. If you have 5 green, you'll put a 5, and so on and so forth. Okay? In order to make your chemical formula, this is about the only thing anybody got mixed up on, was you're going to take R for red, and you have 2, so you're going to do a subscript 2 because you have 2 red. You're going to do an O for orange because you have 3 of them, you'll do a subscript 3. Yellow, you won't even put in your formula because you don't have any yellow. And then you'll put the rest of them, the green, the purple, and the white. The mass, we're giving you the fake masses here of your Smarties. You'll take 2 times 12. So you'll get the total mass of it, which would be 24, 3 times 11, 33, 0, etc., right? Once you get all of your masses, you'll have this total mass here. You can take your part, your 24 divided by your total, times 100, and you'll get your percent R of your total mass of your R Smarties in your whole pack. Okay, so it's just getting you to practice a little bit of like what it would be like to do percent composition. This is useful in a lot of upper level chemistry courses. And I can tell you guys about that next week a little bit, but I wanted to just have this video so you could see, and then I want you to change number 2 in the lab so it says 0.807 grams of carbon. If you forget and you do the argon, I have both works, but and then you'll practice those problems, and then we can go over them on Monday. Have a great weekend, guys.